Very good afternoon, friends, and welcome to the third webinar on the series of problem solving what we started during last couple of months. So, coming to the context of this webinar, today's session is on the problem solving using the QC tools. So, problem solving is one of the very critical skills required for all managers to make their companies products competitive. So currently, all industries are facing a tough time because of the corona crisis. But we can see an opportunity in the current crisis to become a global player of manufacturing product. That can be only possible if our products are globally competitive. To make our products globally competitive, we need a very capable, the right word is the perfect process which delivers the best quality products without any flaw. So that can be possible only if we systematically identify the problems in our processes which are impacting on the quality, cost, and delivery issues, and finding appropriate solutions to make a perfect process. Then only we can be globally competitive. During last two webinars, I have discussed on the very first one how to detect the problems using the value stream mapping. And after that, second webinar on how to solve the problem using the Lean Six Sigma problem solving technique. For solving the problems, we need a set of tools. Larger your tool basket, easier to solve the problems. So here, today's session, I'll be discussing how to use the 7 QC tools in problem solving. This is the most widely used problem solving tools across the world. So this can help you to solve 80 to 90% problems. These are very simple and very easy to adopt. So with some case studies, interesting case studies, I'll be discussing with how to go for it. Now, what is the agenda of today's webinar? So I'll be covering what is the problem solving methodology, then introduction to the 7 QC tools, how to use these QC tools, this problem solving, then case study of a unique case study of express coffee shop, which can be easily understood by everybody using some very interesting products you will see. And then how to use the QC tools in 5-phase define, measure, analyze, improve, control process of problem solving project. So there are mainly 4 problem areas which must be strengthened by any company to make its product competitive. The very first one is the quality, is the most important part. Then comes the cost competitiveness, and third is the on-time delivery. And the most important out of it is the people. Unless the people are competent and skilled on problem solving, we can't produce quality products at competitive price and deliver just in time. So here we are going to address how to improve quality, cost, and delivery by making people to learn the problem solving technique, especially in the today's session, how to use the 7 QC tools. How the problem solving journey is there right from starting problem to the solution. At different stages, different 7 QC tools are used. What are these 7 QC tools are there? I'm sure most of you must be very well aware. Many of you might have used it also in various improvement projects. Now, what are these 7 QC tools? The term 7 QC, 7 tools for quality control, discovered by one of the greatest quality gurus of Japan, Ecafez. Historically, in the ancient days, there was one very famous warrior, Benkei. He used to win most of the wars, and Mr. Ishikawa observed that he was successful in winning the wars because he was having 7 unique set of weapons that was helping him to win the wars. So based on his experiences of Benkei, he identified 7 QC tools and promoted it among the industry people to use it to win the war against the quality defects. And it was really found very, very effective. And everybody was trained in Japan, and they could solve 90 to 95 problems by use of these tools. Today, there are so many advanced tools and softwares you might be seeing. That I have personally seen in Japan on the software, every operator is fully conversant with the tools, these 7 QC tools, and they mastered it and using it. Means I'm again telling not just only supervisors, engineers, but every operator is a conversant with the QC tools, 7 QC tools, and how to use it, and they're using in their daily work and solving the problem. So in India also, what I feel, unless operator level people are made expert on the 7 QC tools, it will be really difficult to get the global quality. So the bottommost line, front line people, they should be made conversant. I hope this will give you some tips how to make the people expert on these tools. So Koro Ishikawa was a professor in the Tokyo University, and he is considered the father figure in the quality improvement of Japan. In fact, his main contribution was creation of a quality circle, quality control circle in Japan, which has revolutionized the Japanese quality and made every operator conversant with 7 QC tools in a various project teams. And because of that, they are able to produce best quality products. So what are these 7 QC tools? The first one is the Flowchart, second one is check sheet, third one is a histogram, fourth one is cause and effect diagram, fifth one is Pareto diagram, sixth one is scatter diagram, seventh is the control chart. The description not presenting at this moment because of the limited time, but this is a very big subject. Only it is covered in 7 days, but here I have to complete it in an hour. So I'm just trying to present an overview and demonstrate how it has been used with a very, very practical example. So the first one is flowchart, where every activity is captured right from start to the end using the standard industrial engineering boxes of process start of entire process to see how the process moves, how the product flows within the process. It is a type of diagram that represents the workflow of a process. This is a starting point for any problem solving. Any problem is there, first you must try a flow chart and have a complete overview of the process. 7QC tool is a flow chart. It is used as a type of diagram that represents a workflow of process. It is a chronological mapping of the process. Second one is the check sheet to collect data so that no mistakes are made in the numbers. Third is the Pareto diagram. It's a very famous tool. This is basically used for prioritizing the problems, because 20% problems make 80% impact on the quality. So it's better to prioritize, select those 20% problems we are impacting maximum. They should be addressed So it is a prioritizing the problems. Fourth one is the histogram, is a plot that lets you discover and show the underlying frequency distribution of a set of continuous data. Like in this diagram, example is given. A group of 20 tourists, they went to see Japan. So the histogram was used, what was the age group of 20 tourists. So here, the 20 to 30, 30 to 40, 40 to 50, in this way, how many people were there. So histogram says well, how many people of that particular different groups were there in the total 20. Then the cause and effect diagram, known as Ishikawa diagram also. So all of you must be familiar, must be using to identify the problems. Then next one is a scatter diagram. It is used to establish a relationship between two variables, as you see, like a height and weight. There is an independent variable, for example, height is independent variable and weight is dependent variable. So is there a correlationship between height and weight of the people? That can be established by using this scatter diagram. Seventh is the control chart, is basically used for monitoring and control of the process. It is generally used after and making improvements are done to make sure that gains of improvements are kept stable. Monitoring chart is used and using the control charts. So how to use these 7 QC tools, like in different phases, as you have seen, the flow chart is for the process understanding. It is used in the define and control phase. Check sheet can be used in measure and analyze phase. The purpose is collection of a data. Histogram, measure and analyze phase for the problem detection. Cause and effect diagram is in the analyze phase for the root cause analysis. Pareto diagram in the analyze phase for prioritization. Scatter diagram in the analyze and improve phase for solution finding. And control chart for the implementation of the control. So these are the typical applications and the purposes of 7 QC tools. How to use the 7 QC tools? Let's take very interesting case study. This is a case study of Express Coffee Shop. It is a restaurant of a 5-star hotel which serves breakfast to 300 guests every day during 8 to 9 a.m. All guests order for a pair of a toast, which is to be served within 7 minutes, but since last 2 months, wait time for toast has increased 12 minutes. This is the problem. Production cost of toast has also increased during the period, right from rupees 20 to 30 rupees, and bread consumption has increased by 50% because of heavy rejection of toast. Manager of the coffee shop was asked by CEO to reduce the cost and improve service quality within 4 weeks. Manager took help of a management consultant like you people to develop a system to improve quality and reduce cost using problem solving. In this typical case study, the quality consultant, he used the 7 QC to solve this problem in an interesting way, see how it has been used. So the problem was solved using 5-step DMAC to define, measure, analyze, improve, control phases, and say 8-step problem solving technique, what we discussed during the last session also. So the very first step is define. The purpose is clarify and define the problem. Before defining the problem, one has to understand the problem. Lean language, it is called grasp the situation, GTS also. To understand the problem related to quality of toast, following actions are required. Understand the process and the product, develop a visual quality standard for product for the waiters and the kitchen people who are producing and delivering it, set target quality as per customer requirements, collect the current quality performance data of process and customer feedback, and then identify gap, and then define the problem. So the first thing to be used is process chart. Here the flow chart is used, how toast is being made, plug in toaster, get bread, insert bread, press the lever, wait, and when it is toasted, pop up. And if it is okay, then serve it, otherwise scrap. Here, the okay quality was badly reduced, so it was helping them to identify with the problem. But the main thing is that, especially in case of a toast, it's a very big challenge for the people, quality people, to define how a good quality toast can be done. For that, you have to design an experiment and make a visual quality control technique to define. Here you see now the nine varieties of toast were presented, classified depending on the quality. First, 1, 2, 3, 4, 5, 6, 7, 8, 9, as you are seeing. These are the 9 varieties of toast are being produced in the toaster. And here you have to identify which is the best quality, and the practical solution is the visual quality. 1, 2, 3 is under toasting, 4, 5, 6 is the desired, and 7, 8, 9 is the over toasting. So this way you have to fix quality norm for the toast. So here, what is needed? 1, 2 you have to discard. In no case we want, that has to be scrapped. Same way 8 and 9. Here the ideal quality is number 5, target quality is number 5, and upper critical limit is 6, and the lower is the 4. So we need our toast mainly in the number 5 quality, but 4 and 6 can also be accepted. But 1, 2, 3, 7, 8, 9 to be minimized. So we have to find solution how to produce our 100% toast in the 4, 5, 6 quality. Let's see. Now, target quality established. It is number 5, and visually it looks golden brown, crisp toast, and it must be served hot. So this is the quality standard for the toast in the Western. So current quality performance data was taken, and 50% toasts are being scrapped due to overheating. That's why it was taking more time, and the cost was increased. Delivery time is 12 minutes instead of 7 minutes. Cost of toast has increased, and customer dissatisfaction increased. So what is the problem? The express coffee shop, during the breakfast, toast being served to customer is not meeting the quality requirement. Most of the customers refusing to eat toast. This problem is being faced since the last 2 months. It has resulted in 50% increase in the cost of toast due to rejection and damaging the reputation of the store. So it's very important to define properly the problem. So this definition gives a clear picture of the problem. Now the next comes major phase. To collect process performance data, you have to collect the data how the toasting process is performed. Here, a design of experiment was conducted to find out what are the factors impacting the process. Then you have to study the toast making SOP, plug the toaster, get the bread, set the timer, insert the bread, put power on, wait the toaster to pop up, inspect the quality, serve it will okay, otherwise scrap. So these are the 9-step process are there. So to solve the problem, you have to first go and see, observe the whole process and try to find out what need to be done. A typical situation observed by the consultant. Somebody has put, the waiter has put the toast and made power on and thought that it will be automatically off when it is toasted. But what happened after some time, a typical smell was faced by the consultant. So it means something wrong happening. This is one of the reasons why toasts were getting rejected. It means system was not working properly. But to find the solution, a design of experiment conducted. There are 2 factors are there: quality of toast and the age of bread. There is a lot of relationship of age of bread here. It means what is the moisture content in the bread. So it cannot be measured directly So indirectly, age of the bread means how long it has waited between a production from bakery to the toasting in the hours. So the 23 samples were taken, and the quality and the age of bread was recorded as you are seeing Q&A, and based on that, the problem analysis was done. So here, after this 23 toasts, so 9 were found burnt, and here 9 quality, what we have seen, 9 categories of quality we have identified in this. So the burnt, defective, acceptable, seconds, best qualities, seconds, acceptable, defective, uncooked. So these were sorted out, inspection was made, and this is the data generated where the check sheet has been used to generate the exact number of quality of the toast which has been made under the design of experiment. So the same data, how it has can be put. Now that was the use of check sheet you have seen. Now the histogram can be used to see the frequency distribution. This is the upper critical limit, 7 here, 2 below. With this one, you can draw the histogram, and in this way, you can use the one of the tools to basically see the frequency distribution. This histogram immediately gives you the idea how this toast quality is being produced in the kitchen. So the same histogram can be used as a bar graph also. The histogram, this shows the normal distribution. In fact, the 6 sigma uses a maximum on the histogram only. If it is a wider, it means your process variation is very high. The purpose is the contrast. Here, all the weight quality must come within the upper control limit to lower control limit. That is the purpose of the interpretation of histogram. So now how the scatter diagram can be used. This is used here to correlate the age of bread and toast quality. You just see the age of bread 5, 6, 7, 8, and 9 hours, which was taken in the experiment. Quality was taken. So the maximum best quality means target quality was number 5. So we got maximum quality in the 4, 5, 6, and the age of 6, 7 hours. Means if the age of bread is 6 and 7 hours, then we get the best quality of the toast, as you are seeing in the circle. So the kitchen people, they must make sure that within the breads must be used within 6 to 7 hours of delivery from the baking oven. So this is giving you guidance. So this is the purpose of scatter diagram, to guide you to find out which is the best combination of the quality and the second variable, age of the bread, is to be seen. Now we have to set a quality improvement target by the team. Now the target is set 95% toast must be in the acceptable range of 4, 5, and 6. So what needs to be done to get 95% in this range? Next comes the analyze phase. Now we have got enough data. So what are the 4 aims? These are the 5 factors which is impacting the quality of the toast. Material factor is the age of bread in hours. It is indirectly, which actually the moisture content in the bread. Then method and man toaster time setting. This is done by the operator. So they must set the timer on the toaster. The method and man factor, toaster temperature setting. 2 settings, the time and temperature setting, that depends on the knowledge of the operator and the accuracy of setting. Then the machine, here what are the failures are taking place? Mostly thermostat failure or the heating element failure. In the toasters, these are the two common problems that was impacting quality. So these are the parameters. This is the problem faced by the kitchen staff, that the over or under age of the bread, wrong time setting, then toaster uh, thermostat failure and heating element failure. Just to improve the quality, these parameters must be addressed. So here, how the Pareto diagram can be used so that we can identify the major critical problem which is impacting 80% of the quality problems. Let's see how this is used. Again, use of check sheet is used for the data collection. So 84 samples were taken. Out of that, it was observed that wrong temperature setting was 9 times. Wrong time setting 14 times. Higher age of the bread 36 times. Heating element failure 8 times. And thermostat failure was 17 times. So 84 data means a lot size of 168 weights were there. And these were the 84 numbers of these failures were observed. It means 84 means 50% breads were rejected because of these 9 problems, and only 84 breads were passed for use. Now, to prepare a Pareto diagram, first you have to collect this number of failures data, then prepare a data sheet for Pareto diagram where the process defects are age of bread, thermostat failure, time setting, temperature setting, and the heating elements. The frequency from the last data sheet we got it, and then cumulative you have to go on adding 36 added 1753, then you add another 14, you get 67 in this way for the frequency, then cumulative total, then percentage of overall total, you take out 36 out of 84, and then cumulative percentage of this one. So you are making this type of table for the Pareto diagram and taking out the cumulative percentage and cumulative total. And based on that, you are drawing a diagram like this one. These are the 5 factors: age of bread, thermostat failure, time setting, temperature setting, and elements failure. So if you just see by making this Pareto diagram, with just cumulative percentage, red line what you are seeing. And once after that, you just draw a line at the 80%, and where it is a cutting, that becomes left side. Means these are the critical problems: age of bread, thermostat setting, time setting. These are causing the 80% of defects. So this way, if you can just control these 3-4 parameters, 80% problems can be solved. So this is the use of Pareto diagram to prioritize the problem. So number one priority of the problem is you must control the age of bread. This thermostat setting should be right. Then time setting should be right. Then temperature setting. So these are guiding you to control these critical parameters. Then after that comes the root cause analysis. The next tool is used. Here the cause and effect diagram is used. They are the 4 factors are there: operator, toaster, method, and the quality of the material. So this way, if toast is burnt, what are the various regions you can see here? The toaster failure is there, thermostat failure, heating element failure, operator not following the SOP. This way, the cause and effect diagram can be used to identify what are the critical problems of. So root cause of poor toast quality after using the cause and effect diagram. The first one is the higher age of the bread. Second is thermostat failure. So these are causing the burning of the bread. Third one is wrong time setting, not proper toasting, wrong temperature setting by the operator, and heating element failure. So these are the 5 problems were identified, but out of these 5, 2 are the most critical, which are causing maximum rejection of the bread. Now, based on that, you have to develop solution. For all 5 problems, solution only team knows that higher age of bread means within 6 to 7 hours you have to use it. Thermostat failure, the quality of thermostat should be improved. Wrong time setting, SOP should be there and it should be displayed so that no wrong setting is done by operator. Wrong temperature setting, same SOP. And heating element failure, the reliable quality of heating element should be used so that toaster doesn't break down. So now, after the solution is found, then you have to make an implementation plan. How it works, make sure that breads being served are produced 6 to 7 hours. Just in 5 days, you have to solve this problem. So here the schedule was made, what action is to be taken, and when, what date, and by whom. So the first is breads are served within and used within 6 to 7 hours. Change the quality of thermostat, prepare SOP for time, temperature setting, and use the reliable quality of bread. This was a action plan made by the team, and they have to implement within 5 days as per the schedule. Then next comes implementation of these action plans to improve. So what was done for these 5 problems? Improvement actions taken, higher age of the bread are procured and stored with production time identification and used according. So time identification is made on the bread packet so that one knows what is the age of bread so that the moisture quantity can control. Thermostat failure, better quality thermostat was standardized. Wrong time setting and temperature setting SOP was made, and all the operators or the kitchen staff they were trained what should be the ideal, and it was displayed in the walls of the in front of toaster. Heating element, reliable quality heating element was used, and it was periodically tested to make sure that it is not failing so frequently. So after making improvements, again samples were taken. 200 samples were checked, and they found the only out of that 10 defectives were there wrong time, because the defectives due to wrong temperature setting 3, wrong time setting 3, higher age of bread 0, heating element failure 0, and thermostat failure 4. So the total out of 200 lost, they got 10 defects, means 5%. So results of improvement. Before improvement in the toasting process, these were the figures. The 45% were coming a defective, and after improvement, only defective came down to 5%. The 55% was a good quality, and it increased to 95% later. So this way, the 7 QC tools have been used to improve the quality. And after the making improvement to hold the gain, the next phase is the control phase, what you have to do. So one very popular phenomena of the entropy, though it is used mostly in the thermodynamics. So the law of entropy, that says, means it is a basically degree of disorderliness. After improving something, if you just leave, again gradually it will come back to the disordered state. Just to overcome that disordered state, you need a control. Here, as the bricks here in the disordered state. To put in order again, you have to go on putting some effort. You have to exercise the control. The same principle applies as per the law of entropy. Unless we add energy through a control mechanism, process will tend to degenerate over time and lose the effect of improvement. Whatever improvement we have done, if there is no control, after some time again, people will forget and will be back to square. So for that, what needs to be done? SOP has to be revised. New SOP, all people must be trained on the new SOP, it should be displayed. Second is the control chart. One of the 7 QC tools must be used. So whenever any output is going beyond control limit, immediately it is noticed by the people and corrective action unit. This is a very, very important tool to monitor and control the process. Then I'm giving one more case study quickly. This was a case study on toast. It was more challenging than engineering products. Here, very quickly, time is just 10 minutes, I'll try to cover it. And during the lean consulting, I helped this company. They were making this product. This is basically motorcycle, motor drum casing. You are seeing how it is being produced. So, name is Autocomp Industries producing rotor casing for a motorcycle OEM. Within that drum, the magneto is fixed to generate power for charging of the battery and the light. So raw material used is hot rolled sheets. Rotor production process include blanking, deep drying, embossing, machining, drilling, and electroplating. During the last 2 months, the defect rate of product increased from 7.5%, which is 3% higher than the industry benchmark. So product return from OEM also increased. So company was concerned about poor quality performance. So the 7 TC tools, how they were used. So again, the 5S problem solving technique: define, measure, analyze, improve, and control. 8 steps were used. The first is process flow diagram. This can be used for the procurement. Here, typical example is given how procurement of raw material is important. It was applied in their purchasing section also, how they should make sure that good material is procured. Then identify main defects in the product. These are the 4 kinds of main defects were identified. First is the electroplating defects that was impacting surface quality. The surface defects like scratches, scales, or unevenness, it was impacting the electroplating quality also. Dimensional defects, the tolerance part of the component, and embossing defects. A lot of embossing is done. If it is misaligned, it will create the problem in the quality. So define the product specification to ensure the quality. As you have seen, what I discussed about, the first thing is that what should be the desired quality. Just in the case of toast, 9 different varieties were produced, and the identified number 5 is the ideal quality target based on the specifications. Here, the 4 kinds of specification were prepared by the team. First, plating specification, surface specification, dimensional specification, embossing specification. Even the visual defects were displayed on the shop floor factory with the actual samples, with the bad one and good one, so that all operators were trained how to visualize, how to select good one, and how to identify the bad one. This was practically done of these 4 specifications. At the same time, failures were, both kind of samples were displayed on a special display board with clear instruction to train the operators. Then the relevant data were collected using the check sheet, as you have seen in the earlier case. This was used to select the 5 kinds of defects. And all the defects, here the 4 kinds of defects were presented in the bar graph, and the operators were trained which graph is which kind of defect coming. Every week this graph was displayed, and it helped even the layman operator to identify what kind of defects are coming. So the visual display of defects in using the bar graph helped a lot to communicate the operators. Just you see, these were displayed on this notice boards on the shop floors, so that each operator was able to understand what is the percentage of problem coming. Then the measurement actual quantification was done. Plating defect was 7.42%, surface defects 5.47%, dimensional defects 0.5%, embossing defect 0.3%. So here the Pareto chart was used. They were trained. It is very clear here. The major problems are coming because of these two, plating defects and surface defects. And the core was the surface defects. If surface defect is there, then it will generate plating defect also. You see the root cause of the quality of the raw material, especially the surface. So investigation of causes was made. Major was the plating defect. One of the major problem of rework is the poor quality of the electroplating. So it was being done outside, outsourced. So the electroplating process was also studied, and they were asked to take appropriate measure in the same way, and that helped to reduce the plating defect. But the main problem was the surface defect. The second most critical problem related to quality is the surface defects of the hot rolled sheets. If you see, the core was surface quality of the problem. If its surface quality is not good, it will generate more plating defect also. So by investigation, it was found that surface defect, poor quality supply from the steel companies. So we'll see how this was solved. So height variation is the dimensional problem, variation in height of rotor due to operational inaccuracy. So the tools dies were accurately used, and the inspection was tightened so that it is accurately measured. Embossing variation was coming due to misalignment of tools. So the problems were identified and the actions were taken. So the analysis was done and root cause was determined. So low plating thickness was coming, incorrect process parameters. Non-uniform coating, poor handling by the plating team. Chipping of plating is one of the main cause of the surface problem. So in the surface defect, unevenness, scratches, dents, slivers, poor operating practices, these were the main causes. These were identified the team, and the solutions improvement actions were identified, and these actions were taken. Process parameters standardized, operational discipline improved, handling practices improved, quality control practices started, and a lot of improvements were made in the purchasing process. Purchasing procedure was standardized. Steel purchasing started from Tata Steel and some leading brand suppliers instead of local small companies. That helped to improve really good quality. Incoming quality inspection incorporated, production process standardized, handling practices improved to prevent damage. All operators trained on new improved procedures. Quality control practices started in the purchasing. So these were the improvement actions taken by the team. And then finally, after implementation, all the improvement activities. So for post-improvement, the control chart practice was introduced, and they started measuring and displaying. So this was made accessible to all the operators, even the operators without statistical background. They were explained in the local language how this control chart can be. And within few months, they started understanding it. So because the number game, percentage and data can be understood by educated engineers, technicians only. But the operators, they can't understand the tabulated numbers, percentage, and complex data. So these 7 QC tools, in addition to finding solution, it provides very, very powerful visual communication to all the operators, those who are not having any proper education background. So one of the very, very important aspect of 7 QC tools, it communicates visually and most effectively even to the people who are not aware about statistical techniques. So result of improvement efforts in this, you can see the plating quality was 92.58%. It went up to 96.24%. Surface quality 94.53, 97.77. These are the actual figures of a company that's located in NCR region. Now I'm just summarizing how to use the 7 QC tools to solve quality problems. First, select a problem. Form a project team and train the team members on the 7QC tools. Measure the current performance of process. This becomes your baseline performance. Investigate and analyze the root cause of the problems. Develop and improve. Implement appropriate solution. You have seen how it can be used. Confirm the effects of improvement, improved working, and finally, once you get the desired result of improvement, standardize, monitor, and control the new method. And you must celebrate the success to motivate the team for the good work they have done. So this way, 7QC tools you can very effectively use, but you must train your all operators. It should not be just limited to supervisors and engineers. And display on the shop floor, as I have explained you, all the visuals of data, bar graph, Pareto diagram, control charts. These figures can be used with the visual graphics and can be displayed, and the operators who are producing it, they should be trained so that they can also feel pride in reading it, understanding. This will not just help to improve quality, but this will improve self-esteem of your operators who are producing it. Once they will start seeing these kinds of displays on notice board, that is a display of their performance, and they will feel pride. This will improve their self-esteem and motivate them to improve quality, understand the deficiencies. So this way, 7QC tools can be used. So this is more detailed you can get. This is the book. Most of the case studies and the methodology discussed in detail. In this book you can find, you can refer by all other previous webinar presentations, case studies, and the future upcoming webinars. So after long experience, I compiled this unique book with just few months back. It has been published. So with this, I conclude and thank you very much for your patient hearing. I'm happy to now, I'll be happy to give answer to your questions.
So I request everyone, if you have any questions, please raise your hand and we will get in touch with each and every one of you. Or you can also type in your questions with the help of the questions tab.
सर डिफरेंस बिटवीन ओल्ड एंड न्यू पीसी टूल्स में क्या है डिफरेंस? मतलब डिफरेंस क्या है? न्यू पीसी टूल्स भी है ना?
Yeah, there is a difference. There are different tools are added, but first you must master 7QC tools. This is the most important fundamental.
Okay.
There is a difference because means there are every day lot of tools are evolving. So as per the Japanese experience, I found that these 7QC tools are fundamental. Only after that you can go for many tools.
Yes, Mr. Rohan, do you have any other question? Yes, Mr. Shiva Kumara N, please ask your question. So there is a question, how to implement cost effectiveness.
This is cost effectiveness by using the tools.
Yes, sir.
It will be cost effective. By minimizing the waste, what I discussed in, I'm discussing only all the tools, this 5 webinar series prepared only for improving the cost effectiveness. We just identify the problem solving. So once your waste are minimized, automatically it becomes, your product becomes, your operation becomes cost effective. Means your cost comes down, so it becomes. So all these tools are to enhance your cost effectiveness only. By use of these tools, you are going to reduce your waste. If your waste are reduced, then the production cost will come down because of your wastage cost is reduced. So you become cost effective.
Thank you so much for your time and your knowledge, sir. We don't have any more questions. So we can conclude today's webinar here.